Hi Engineering Janta, I am Vaibhav Shukla and today we are going to further learn peak function, is empty, is full in the implementation of stacks. You can consider it the part 2 of stack implementation method 1, and this is another video in the free DSA series that we are building for you so that you guys thrive high in your career. Fine. So I'll go ahead and let's straight away dive in deep because we have studied till here, we have studied till pop function. So today I'll go ahead and I'll show you the peak function, is empty function, is full function. Moreover, today we'll try and implement the stack in the main function. Okay, basically we'll use these functions today in the main function. Fine. So straight away going ahead with peak. If you remember, I told you that peak is just like peeking into a window. Fine, it is as simple or as same as that. So whatever is in front of you, fine, you have it as the output. For example, if you are peeking into a kaleidoscope, if you guys know that there was an instrument in class 7th 8th that we used to build, kaleidoscope, in which there are multiple mirrors and from top you can see it. Fine, so you have a few beads. So whatever you see from the top, that is the first thing that you notice, and then you notice what's going on in the mirrors. Fine. Or say that there is a box. In that box you're looking from the top, you're peeking from the top. So in that case, whatever you see in that box from the top is what you will return as the output, right? Same does the peak function. For example, if there is a stack and you have 3 say elements in it, 15, 14, 17. So whenever you apply peak function, it will see this particular element which is pointed out by top, fine, and it will return this particular element. Fine. Now if you carefully see, here also the same is happening. First of all, we are checking whether the stack is empty or not. Fine. If top is less than 0, which basically means if top is pointing at -1, if top is pointing out here, then definitely this is all empty. We have discussed this in detail. If you do not know why top is -1 when the stack is empty, go ahead, watch the previous 2 videos, you'll realize that. Fine. So I come here, I check if top is less than 0, then cout stack is empty, return 0. Fine. So this would be printed that stack is empty. But if stack is like this, you have some elements, so top is not 0, hence this will not execute. So whenever stack is not empty, what happens is you declare a variable integer x and you assign the value to this x as the value that is present at top, the value that is present at the index pointed out by top in the stack. Fine. Now moving ahead to is empty. Fine. So what does this particular function do? This function is basically a replacement of this. Fine. Why am I saying so? This is a true or false, a boolean function. Fine. This will tell you if top is less than 0, then return. Fine. So if top is less than 0, if this condition is true, then it would return true, otherwise it would return false. Basically what I am trying to say is you have to return whatever this condition is saying. Basically top less than 0, if the output of this condition is true, then return true. If the output of this condition is false, then return false. What I am trying to say is this. Say for example, this is an empty stack, right? In this empty stack, your top is pointing out here. Fine. Top is pointing out at -1. In this case, top is less than 0. So this particular statement is true. If this is true, then true would be returned because the return type is boolean. The return should be either true or false. In case the stack was not empty, say that we had a stack and in that we had two elements 15 and 14, and top was pointing out here, which is 0 and 1. Fine, say that 0 and 1 are the indices. Fine, I guess 1 is not quite visible here, so I'll manage that out. So now I guess it's good. Fine. So in this case, when top is pointing out at index 1, 1 smaller than 0, is this true? No, it's not. This condition is false. Fine. So now false would be returned, and henceforth if you see, the stack isn't empty, hence the output of isEmpty function is false. When the stack is not empty, this isEmpty function will basically return false. Fine. Now similar way isFull executes. Fine, we try and see what happens in isFull function. What you check is top equal to max minus 1. If you correctly remember, max is the value which was assigned the value of size. I'll show you. So if you see correctly, here I assigned the value of size to max. Fine. So now max is nothing but the total capacity of stack. Say the total capacity was 5. If there are 5 elements in the stack, fine, it is filled till top 18, 19. If it is filled till top 0, 1, 2, 3, 4, and top is pointing out at this. So this final index, the topmost index where the stack will become full, is actually max minus 1. If the size of the stack is 5, then max is 5, and the topmost index would be max minus 1, which is 5 minus 1, which is equal to 4, which is this index, right? In this case, if top equal to max minus 1, so in this case what I'll do is we'll try and write the values for it. Fine. In this case, top is for max minus 1. Let's check. Max minus 1 is 4. We just calculated it. Fine. So 4 is actually equal to 4. This is true. This condition is true. Henceforth, true would be returned. And in this case, if you see, the stack is full. Henceforth, isFull should return true. And in this case, it is returning true. Just imagine you didn't have this element. Fine. So your top was pointing out here. Fine. Now max minus 1 is still the same. Max minus 1 is still the same, 4. But in this case, your top is pointing out at 3. Fine. The top pointer, is pointing out at 3, which basically means the value here would be 3. This 3 is quite designed. I would replace it. So 3 equal to 4. Is it true? Is it true? No, it's not. 3 can never be equal to 4. So this is false. If this is false, then isFull would return false, which basically means the stack is not in the overflow condition, which basically means you still have space for pushing an element. Fine. So this is how you implement these 3 functions. Now display function. What is this display function? Nothing but it is saying show me the elements that are in the stack and show me all the elements in the stack. Fine. But in this case, again you will go from top and you will come till bottom. Fine. You will not start from the bottom. I'll tell you what I'm saying. See, consider a stack where you have 17, fine, 17 is what I wrote first, 17, 16, 15 and 14, and you still have some space left. Top is pointing out here. Now 0, 1, 2 and 3. Fine, these are the indices. In this case, first of all you declare a variable I which is equal to 0. Now if you check, if top equal to minus 1, if top had been -1, then the stack would have been empty. Basically, the emptiness of stack is being checked. Fine. If it was the case, the stack is empty, you can write and return. If it is not the case, then what to do? Then you apply a for loop. Fine. You initialize I with top. Basically, I starts pointing out here. Fine. Till I is greater than equal to 0, which means I can go up to 0th index. As soon as I becomes -1, you will stop executing this loop. Fine. Till this condition is true, the loop will execute. Fine. Now I minus minus, which means I is decrementing at every step. Fine. Now if you see, I am printing out the elements at that particular index, which basically means now top is 3. Fine. So I is 3. I print out a of 3. Fine. We'll print this. So the first value, if I write output here, fine. So the first value that you will get is 14. Then a space would be printed. Fine. This is just for cleaner code and cleaner output. 14. Then 15, because I would now decrement. Fine. I would now decrement. If you correctly remember, I minus minus happens after the successful execution of this statement. So I minus minus takes place. I comes here. Again, I'll check. Now this was the initial condition, so you need not come here. I is 2 now. 2 greater than equal to 0. Yes, this is true. So again this would be executed. What would happen? A of 2 would be printed, which is 15. I printed it. Again I would decrement. Fine. Decrement the I. I comes here. Fine. I becomes 1. Let me write it more clearly. Now I becomes 1. 1 is still greater than equal to 0. Again true. Again you print it. A of 1 you print. Earlier A of 2 was printed. Fine. So A of 1 is printed. What is A of 1? 16. Fine. Again you decrement I. I minus minus takes place. I decrements. Fine. Whatever. But I erased the completing. But it will go till last. You'll understand. Fine. Say that we were here somewhere and 17, 16, 15, these were the elements. Fine. And say that, and 14 again. And say that 14, 15, 16 were printed. And last I pointer after decrementing would come in the last place, which is 0th index. Now in this case, again 0 is equal to 0. This is true. Once this is true, you will print A of 0, which is 17, and post this decrement would happen. I minus minus. Now I becomes -1. This loop would stop functioning. Fine. But the interesting thing to notice is that you're printing from top to bottom. So even when you're displaying the stack, you display in a manner where the last element added is shown first, and then the chronological order of adding the elements is followed. Basically what I'm saying is, जो लास्ट में आया वो सबसे पहले दिखेगा, जो सबसे पहले आया था वो लास्ट में दिखेगा. Fine. In this manner you print it out. Fine. Now let's execute a stack. Stack S of size 5. So if I go to the initial page where we had stack int and size, basically we declared an integer type of size for a stack class. So in this is just a constructor, if you see. Fine. So this is for defining itself. Now in this case, if I go ahead, you have a stack where the capacity is 5. Fine. When the capacity is 5, what you will do? First of all, push will happen. So push 5. I have explained how push works, how pop works. Go ahead, watch the previous video, you will understand. Push 5, push 10, then push 15. Fine. Push 20. Now top would be pointing out somewhere here, right? Now see out S dot is empty. Now if you print this out, what will come? Fine. Nothing. This will return false, because it is not empty. So first thing that would be printed would be false, right? Because is empty was a Boolean function, fine. So it would return false. Now is full, it is still not full because there are just 4 elements that I have added. We can add 5. So again false would be returned here as well, fine. Now I say pop, fine. When I pop, then in this case what will happen? Whatever is present on top would be popped, fine. So 20 would be printed out and the top would be decremented. Top would start pointing out here and we will forget this element, fine. So in this case you'll have this output 20 element popped from the stack, fine. You will have this sentence also written in the output. Then you display. Now when you do display, what will happen? These 3 would be displayed in an order where you will have 15, then 10 and then 5, fine. In this way it would be displayed, and that is the first method of implementing a stack. And this is how the method 1 concludes. I have shown you how you can implement a stack even in the main function, fine. I have shown you the working of all the member functions that we wrote, fine. So whatever good you learned, go ahead, spread it out, spread to the people who need it, fine, and keep doing good without any expectation. Good will come back to you, believe me. Top 3 comments stand a chance to win Prepinsta Prime subscription for free. So go ahead, comment below this video, and if you're regularly watching this series, you'll realize that one of the user has recently got this in a giveaway, fine. Also follow these links that are also given in description, fine, so that you do not miss any hiring update. If you're facing any blocker, any issue in the explanation, go ahead, tell me. If you like this explanation, then also tell me. Whatever you feel like, fine, go ahead, comment. And also if you feel somebody needs this explanation, go ahead, teach them on your behalf, fine. Have a good day, have a wonderful day.